Okay, let's go very quickly to visualization of data in R. That will be a quick primer on the use of ggplot2. Why? Because, well, we have seen so far a few ways to plot the data. Pairs panels in package size gives us the SPLOM, so the scatter plot of matrices. If you give to pairs panels a data frame, you will get all these correlation matrix, and then we saw that in the video introductions. We've seen ezPlot to visualize data for ANOVA. We've seen the box plot when we talked about outliers again in the video lectures. There are other plotting functions. For example, this plot function gives you a scatter plot. Hist gives you a histogram. This is a function that I didn't teach about, but you should know. Dev-off essentially closes the plotting output, so that if you have a plot, like let's plot the numbers between 1 and 10. Okay, this is very small. Okay, this may be better. You plot the number between 1 and 10. If you do dev-off, you throw away everything and you close the connection with the plotting device. I call it a plotting device because you can have other plotting devices. For example, it could be a PDF file to which you are appending plots. And at some point, you close the connection and you close the file. So the file, you can open it with I don't know, Adobe or something like that. If you don't do that, you keep adding plots to the device. Okay, but these functions are not the best in terms of elegance, in terms of beauty of the plot and customizability. I mean, you can also customize the plots quite a lot in R, but so you can change easily the name of the x-axis, the name of the y-axis. You can change, I don't know, the appearance of the axis and of the box around the plot. You can do quite a few stuff. You can change the shapes here. But the ggplot approach is different, and I mean it's the most modern approach we think there is in R. And I mean, after some struggling, because I cannot hide from you that it involves some struggles, you can obtain very beautiful plots. But ggplot has its own logic, which is completely different, or very much different from other plotting functions. So the ggplot function by itself doesn't give you any visualization. So inside the package ggplot2, you have a function called ggplot whose job is associating graphical elements. I mean, also first job is tell the function which is the data you want to visualize. The second job is you want to associate graphical elements to variables in the plot, in the data. So that's called the aesthetics. For example, you want to draw a scatter plot, okay, but what is the variable that I want on the x-axis? Well, it's the independent variable. So the variable on the x-axis is associated to, I don't know, number of cigarettes per day. And what we want on the y-axis? Well, the dependent variable, which will be the size of the liver. And you associate those two. You have different groups, maybe. You want to associate those to different colors. Okay, so the color aesthetics will be associated to the variable groups, and so on and so forth. So each possible graphical element can be either fixed to a value, so you can decide that, I don't know, the color of the dots is always red, or it can be associated to a variable, and then that graphical element will vary according to the variables. But that doesn't give you any plot. So if you do only this, you're only informing ggplot about the aesthetic, so the association between the variable and the graphical element. But then you need to add what is called the geom. The geom are geometrical objects, things that you want in the plot. You can have, there is plenty of geoms in ggplot. You cannot know all of them by heart. You have geoms for points. You can have geom for lines. Smoother. Smoother means a regression line that fits your data. With different type of regressors, like smoother, linear regression, and other things. You can have geoms for histogram, for box plots, for Weiling plot, for anything. Like the best thing, what I typically do, is not learn all possible geom by heart and all the options, because it's endless amount. I just Google. I want, how do I get a bar chart? ggplot, bar chart. And then I typically go to the images, I see the plots that I like, I say, I want my plot to look like this one, in terms of the geom I'm interested in. And then, after that, imagine in some occasions you want different plots according to some variable. For example, you want a different plot for the experimental and the control condition. Well, the way to do that is Facets. So, thanks. You want, if you want to split the plot in different graphs according to some condition, the function is Facets. I mean the function, the type of function is Facets. Then you have a couple of options for that. Other things that are a little bit more advanced are the scales functions that allow you to set options for the aesthetics. So, for example, ggplot, if you want to associate a variable to color, it will choose a color palette that is the default color palette. If you want, you can also change the default color palette, so decide that the colors that are associated to different values of the variable are, I don't know, first red, then green, then blue, then yellow, etc. That are the scales. Then another thing is the themes. The themes are global options that affect the appearance of the graph. Like the, for example, which font we want to use, or whether the axis will be present, whether we should be thick or thin, whether you want a grid to facilitate you in locating the points or not, whether you want a background color and all this, additional stuff that are not important for the content of the graph, but are important only for aesthetic purposes. There is this beautiful page, ggplot2 tidyverse, that includes all the information you need to use ggplot. I mean, it has courses, it has help files, it has everything that to introduce you to all the functions in ggplot. Okay, let's load ggplot2, also the package reader and the deployer, and import the BPD data so that we can try a couple of plots. So here to our pilot code, we add, let's make this bigger. We can add ggplot2 reader, which we will use to read the data, and I'm forgetting something, reader, deployer. Okay. And then let's import the BPD data that we should all have here. So we go to our BPD data, right here, and we copy paste this code here, and we read data BPD data. Okay. So first thing, imagine that we want to draw. Oh, okay. Let's wait for a second. Maybe did you manage to load the packages and the data? Okay. Anyone needs help with that? Okay. So imagine that we want to draw a plot that has the borderline personality disorder checklist on the x-axis and the SCL, SOM, which is the somatization from the symptom checklist. And we want the BPDCL on the x-axis and the somatization on the y-axis. The function, the first thing we need to do is ggplot. The first argument is the data, BPD. The second argument is the mapping. The mapping includes typically the function AS, which is aesthetics, in which each aesthetic of our interest is mapped to a variable. In this case, will be the BPD CL, is the borderline personality disorder checklist, on the x-axis, and on the y-axis, the SCL SOM. If we do this, we don't get any plot. We just get an empty plot in which we have the BPDCL on the x-axis and the somatization scale on the y-axis, but nothing in there. Why? Because we did not add any geom. For example, what could we add here? And if you want to, this I should tell you, the geoms and the facets and all the options are added and separated by the plus symbol. So you add, literally add layers to the plot. For example, geom, if we write geom underscore, we see all the options that we have. There are quite many. These are all options for geom. For example, let's add maybe the most simple one, geom point. The point geom is used to create scatter plots. Well, makes sense for us. If we add the point, here is our scatter plot. We can also add geom smooth, and we get a smoother in that. It's with the GAM method, but we do have the option to ask method equal to linear model and have a linear model fit in there. Now, how do I know that? How do I know that? It's because I remember. But if you don't remember, you just go on Google and ask gplot to fit regression line. Adding a regression line to the ggplot, and you see here someone probably tells you geom smooth method linear model. So, and also some other options. So if you Google that, I mean, the ggplot 2 has a huge community of people that are helping people, so you don't even need to post your question. It's probably someone else already posted it and it's been solved like 10 years ago. So here it is. I don't know, imagine that we want to, I think we had different colors for therapy condition in this data set, the variable therapy. Imagine that we want to associate a different color to each therapy condition. We can do color equal to therapy. Then we run, and we get 3 regression lines, and the points have different colors for each of the therapy groups. Imagine that we want, I don't know, let's complicate this plot a lot. A different shape for gender, like for males and females. I think the gender in here is sex, yes. So we do shape, shape equal to sex. Here it is. Now even more complicated because we have males and females, and also my plotting area is very small. So yeah. Now it is visualizes a little bit better. It's quite crowded. But still, you have different regression lines for males and for females in different therapy conditions, for different therapy conditions. This is quite crowded, not very beautiful plot, but just to show you that setting up the plot can be a little bit complicated, but you can really build on that and add things very easily. So I don't know what else we could add. Maybe we can decide to remove the color and the shape options and return back to the simple plot, which is easier to visualize. We only use a few aesthetics. You can associate to a variable the x-axis, the y-axis, the size of everything you have on the plot, the color, as we've seen, the fill. Actually, sometimes you have the color and the fill are different. So the color is the border color and the fill is the filling color of some shape. The shape is for example, when you have dots, you can have triangles, you can have circles, you can have squares, and those are shapes that you can associate to variables. Okay. A typo here. You also have, of course, the help files built in, like you can do question mark, geom, I don't know, area. And it tells you something, like for each x value, geom ribbon displays or the y interval defined by ymin and ymax geom area is a special case of geom ribbon where ymin is fixed to 0 and y is used instead of ymax. I didn't understand a thing. So the bad part of ggplot is the help files, the built-in help files are horribly complex to get. I mean, that are difficult. For me, the easiest thing is to Google, to search on Google, because on Google you see the images, so you see the outcome, and that's often much clearer than reading a description of what you get on the plot and so, what? It's geom ribbon, I have no idea what it is, so complicates things. But you still have an help file. So, but that, I think we are just getting into the logic of ggplot. So associate variables and map them to graphical objects, and then add layers of geometric objects. You can have as many associations as you want. You can add as many layers as you want. Of course, at some point your plot will become ugly and too crowded. We've seen that already. We can also specify options in the geom, like we've seen method equal to linear model. We can also have, I mean, one of the things you may wonder at the beginning, you see this shaded area around the linear regression. It's because it plots the standard errors. You can ask to, you can turn them off and only have this line, straight line without the shaded area around the line. Now the facets. The facets, as I told you at the beginning, you need facets when you want to split your plot according to some variable. You have two options, actually, two main options. One is facet grid, and the other one is facet wrap. So facet grid means that you want to arrange the plot according to one or two variables in rows and columns. So, for example, imagine that you would have gender and therapy. You may decide that gender defines different plots and they are arranged in columns, and therapy defines different plots that are arranged in rows. That's facet grid. The annoying thing about the syntax of facet grid is that for some reason they decided that the variables are specified with something that looks like a formula syntax. So if you want gender, for example, as rows, you do facet grid, you add the object facet grid, and you put gender tilde dot. Don't ask me why they decided this, like the variable tilde dot. Dot means don't split anything for columns. Or you use facet grid dot tilde a variable to say, arrange my plot in columns. You can specify both rows and columns to obtain a grid, three-dimensional grid of plots. Facet wrap is somehow similar but easier to use. you have tilde and all the variables that you want to split the plot, but instead of arranging them as in a well-ordered grid, it just places them one after the other from left to right, from top to bottom. So it's more. I mean, it can be useful, for example, when you have many variables you want to split your plot for, and you don't care very much that they are arranged in a special grid. For example, let's try visualizing separate scatter plot by sex, by therapy, and both. What can we do? Who's going to help me? I need a volunteer. Let's spice this lesson up.
They are scared.
Yeah, you can.
I can. What was the?
I am passing. No, come. So I want you to try to get this scatter plot for males and for females separately by rows. Yes, of course. I know the keyboard is different. I know that.
I have to.
Yes. It's this.
What is the?
This.
Okay.
Yeah. Okay.
Where is tilde?
Oh, the tilde.
I have to.
Yes, I can get it for you. It's just outside the parentheses. How about you know how to do that?
Yeah.
I should have picked someone else. Awesome. You see it?
That's good.
Perfect. You can return it to your. And you also have some very good graphs in there. So, yes, you can split with Facet wrap. They get arranged as a sequence, like from left to right. So I can add sex, I can add therapy, and here I get. Okay, this is a very small. I have to make my code a little bit smaller here to get a better visualization. So, but I get a separate scatter plot for females in control condition, for females in this condition, in this condition, and then for males. You see, there are 8 plots, but they are not arranged in any special way. Otherwise, I can use Facet grid. And do like this, sex and therapy, and I will get the gender on the defines plot of different rows, and the therapy defines different columns. So that's Facet grid and Facet wrap. I mean, this, in a way, as usual in R, the easy things are very complicated. So getting the first scatter plot is a pain, but once you get the first scatter plot, making it very fancy and complex is very easy. For example, some people don't like all the grid stuff behind the plot. You know, all these aesthetic choices that they made in the default plot. Well, you may really change the appearance of this by adding a theme. Theme, black and white, for example, gives you this. It removes the color, removes some of the things.
The line is blue.
The line is blue. The line was blue also before, but yeah, we couldn't see that because the screen is not very accurate. But
gray.
You can have theme gray, for example. It seems like the default one, but
there was a gray with a.
Oh, which just another version of the same thing. Theme dark. Let's try theme dark. You see. Whereas in other, like in the standard R plotting, if you want to change those things, you need to really manually figure them out. Here you can just choose among a theme minimal. Is this? I will find a way to remove all the grid theme line draw, maybe like, yeah, very intensive. Theme void, oh, nothing, very clean. Not even the axis levels. I mean, you can try many of those. There is also a package GG themes that includes many other themes. Like I like. So let's try to load this package GG themes because it includes additional themes that you can use. And I like, for example, this theme view that is only in that package. Very clean, very clear. And you have many options for personalizing the plot. So when you publish a paper, you want to put a plot in there. ggplot2 is like a good way to do that. Okay, this is the facets, the themes. Yeah, these are some themes that I suggested you to try, but there are many more. And the general function theme also allows you to set all options manually. So if you just use theme, you can decide all these options and set them manually to obtain exactly what you want in terms of appearance of the graph. And you can also have the theme function to personalize. I mean, you can start, for example, from theme view. Then you add theme, and you can use this function to personalize things. Like, I don't know, axis title X top, axis title X border. Doesn't work, of course. There are many options, and you really need to read what these are before using them. Axis title X, label axis, specify axis level by plain using.
If you have to write element text and
oh shit, that's true. Okay, that's very annoying. So you cannot just give it. Yeah. Let's try this. Doesn't really like it because when you want to specify some textual element, you need to specify also the aspect of the textual element with a function element text. So it gets complicated, like very complicated.
But I think this is just the properties, not the text.
That's true. I mean, it's okay. Don't manually edit the theme. But if you really want to manually edit the theme, I mean, I swear I did it before and it worked. But what I typically do again is Google how to edit the x-axis in ggplot, and that's probably the easy stuff to do because it has so many options, so many articulated options in terms of graphical appearance that you cannot possibly remember even like 1% of them. But the good part is that you can really, if you want, you can personalize your plot in its specific elements.
I Google it and it's plus labs, and then you specify what you want to be the title on the X and on Y. Labs, LA, without theme.
We can just have
Plus labs, and X equals, I don't know, something.
Okay.
Or,
yeah.
okay.
Thank you a lot. So yes, you can personalize everything in this plot in terms of all the. I mean, for example, you can rotate these numbers, for example, and put them vertically. You can literally do anything you want in here. Put textual elements inside the plots. I mean, you can personalize the graphical appearance of your plot in all its finest terms. But I mean, the main the arrangement of the data within the plot. For that, you only need the aesthetics and the geoms, and maybe the facets, and that's it. And then all the style that you want to add to your plot, that can get more complicated, of course. Okay, and that's, okay. Of course, I showed you a scatter plot, but of course you can have histograms, you can have box plots, filing plots. These are all exercises. I will show you some options for that. Like, for example, we want to draw plots that involve a single variable, maybe. let's do this. Data BPD. And this, or maybe let's do this. On the x-axis we have therapy condition. On the y-axis we have this somatization. And then instead of using the points, let's start from scratch. We do geom, hist. Let's see. Oh, geom histogram doesn't like it because it only wants one aesthetic. So let's have y on. Okay, here. Maybe let's put somatization on the x-axis and then a histogram. We can also have somatization on the y-axis and then ask for a box plot. Box plot. We can have, in the box plot, I think we can also have x-axis, so therapy. Then we have multiple box plots. We can also add geom violin, and we can add of a box plot and then on top of that a violin plot, which is not aesthetically very pleasant. So remove the box plot and get a violin plot. And we can again, for example, this is something that we sometimes see, geom point. I think, yes, that you can also have jittered points. Jitter means that the points are arranged a little bit more on the randomly on the axis so that they don't overlap. And you can, of course, regulate the amount of jitter on the x-axis and the y-axis. In this case, I will just jitter them on the x-axis.
What does the violin show?
The violin is essentially like a density plot, which is like a Rorschach picture is split symmetrically. So essentially, you see that this curve is the density of this variable, and this curve is the same thing on the other side, reflected on the y-axis. And you see the distribution, yes. Then you see that here you have, in the control condition, you have a little bit more in this area, and in this condition, you have a little bit more of somatization in this area. So those who like the violin plot say that this is more informative than, for example, the box plot, because it informs you about the whole distribution of the variable and not just regarding the summary of the median and the quartiles. And I will say, well, color we have already seen those, and I will say that's it. I mean, that's it for the moment. And that was supposed to be the last lecture, so I wanted to spend a few last words regarding R. So, especially for people who are new to R, and for all the topics that we thought about during this lecture, you will have, I mean, we only scratch the surface, you have plenty of options, plenty of possibilities, and especially if you are at the beginning, R can be scary, it's okay. You may feel a little bit overwhelmed. I did when I started R as a PhD student. It was a bit overwhelming because it is like if you are a video game player, it's like a huge open world video game with plenty of possibilities, and you feel that you may feel lost. It's okay, it's normal. The good part of R is that being an open world game where everyone is building content, you have plenty of possibilities that you can explore, and you, over time, will find your own way to code, your package that you like, etc. But the most important thing is you need to be aware that it takes time and effort to learn R. I mean, it's okay to make errors. It happens often. I mean, I just made an error in a paper that we published. So yeah, that's true. We published a paper, beautiful paper, and I made a coding error and screwed up a figure. So and I've been coding in R for a lot, 10 years now, about 10 years, and yeah, it happens because R is complex. It's easy to make mistakes, and you just need to learn from those mistakes. And yeah, be patient. But the good part of R is that you will really find what you need. And you can do anything. Like there is no almost no limit to what you can achieve with R compared to other software that are not open world games, that are closed world.
And write papers.
You can, yeah, you can write.
Write papers. Write papers.
Yes, you could write papers directly in R. That's true.
So,
Yeah, you can.
no, what I mean is that they don't know.
Ah, okay. You can, for example,
They can think that R is only about statistics. Instead, you can use it in other ways, and there are packages of R. You can write directly your paper, including directly your tables from the analysis. Directly. So
Yeah.
as you change the analysis, the results update your paper, and you have all ready at the same time.
Yeah,
You don't
that's-
need to do analysis, copy and paste, and then write the
Next
paper.
summer school.
another summer, so exactly. But that's not, I mean, that's actually just this.
I don't do it, he does it. I mean, I'm not.
This is quite easy actually to do. It sounds more complicated than it is. You go to new file, R-Markdown. You give it a title, so my paper. You want, I start from the HTML format because it's easier to compute, but you can also have PDF and Word. Sometimes Word is very convenient. Well, let's do Word. I don't know if I have all the required packages here. And for example, in my paper, okay, this is just a pre-set up text. So you have, this is an R-Markdown document, Markdown just blah, 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 blah. Here, so with the hashtag symbols, you put titles. And these are code chunks. So these things are things in which you can include your code. And this is, outside this, you can write whatever you want. So like, let's do this. Like this is my new paper. I will surely publish it on science. And then let's take, so take the code that we programmed before, we put it here. And then we take some of the code, for example, for a plot. We put it here. This is the plot that will change how we treat BPD and think about science. That's it. And then, okay, we can also equal to false means that, I mean, you have some options for these chunks. For example, ask R not to put all the code inside of your paper, but yeah, for the moment we just don't care that much. We save it, my paper, and then we go to knit, and we wait and see if it works or if it gets stuck for some reason. Huh, it works. Yes, my paper, docx. Yeah, this is my paper. Okay, that's annoying because it gives you, it's outputting all the code here. You can just delete it afterwards, or you can say, oh, but this is our paper. I mean, this holds for complex, simple and complex analysis. It's just that to write your paper in R, you just want to write the text outside the boxes and the code inside the boxes, and that's it. It's very useful. I mean, typically, don't write a paper that you send to science directly with this. It's called R-Markdown. But what you do is, for example, I want to write a report for the analysis that I am doing, and I need to send it to the coders. Then the problem is it takes time because, for example, you realize that at some point you did not exclude 10 observations which shouldn't be there. For example, where you tried the experiment beforehand 10 times, and then those stayed in the data. You want to remove them. But if you do that, you have to rerun all the analysis. So you prepared your report. You realize that you have to change all the numbers in the tables or the plots, and then spend like 1 hour trying. With this method, you just make a small change at the beginning of your script, and you get the updated version of all your analysis very easily. And you less error prone because you don't need to copy paste the output and stuff like this.
Just one question. Do you write the old paper or just the method in this way?
There is also APA formatting directly.
Oh yeah, you can also format the tables using APA format, so there are plenty of options. But yeah, I've never written a paper all like this. I typically then you edit it a little bit because of the fonts and stuff. But then you can, in principle, you can write a paper.
Felix is doing always this. Felix.
Yes, but maybe it does in LaTeX, right? Yeah, but okay. Just essentially, R-Markdown is a combination between LaTeX and R. So you can do that.
If there's a package CG stats that creates directly APA tables.
It creates?
APA tables.
Yeah, that one.
CG
So
stats.
SJ stats, and you can get APA tables.
It's a package that you have to add, right?
Yes.
Okay, because I didn't find it.
I mean, yes.
And you can also create presentations.
Oh, yes. You can, for example, the whole presentation on power that I gave you, and then I will let you go to the coffee break because I know it's late. I created originally, honestly, it's the only one that I created completely in R, or maybe no, maybe I have another one. But this is the original lecture on power analysis from which I took some pieces for today. This is a presentation, and it's completely created in R. So you get all the code examples, you get the description of power analysis in R, and you can have, you see here, you can see the code, you can see the result. But the beautiful thing is that if you want to teach power analysis, for example, you create a presentation with R, you give your student the presentation, but the presentation includes the code. So they open the presentation, the original, the underlying file, and they have all the code and all the output origin, and they can compute it on their computer. So they can take the code, etc. So yes, you can do also presentation. They turn out to be quite right, actually. But yeah, like you can include formula with LaTeX inside the presentations or the papers, it depends.